Yeah.
Okay.
Yeah, so sitting back there. This one player is
Yeah. What's up,
Well,
Kurt?
it was part of like the whole
so our
sec
JAG
war engagement stuff. So.
our JAG left during the shutdown. He's like, because he was civilian. He's like, screw this. I'm finding another job. I don't need this.
That's okay.
So our green suitor took over, and he had no idea how to do the review process and who the approval. So finally, our general signed off on it, but it's like Wednesday.
Defeated by,
Yeah, he's like,
Bureaucracy.
Screw this.
yeah, we were just kind of like, all right, well, let's see how it works out. Nobody's told me no yet, so.
I'm still half expecting to like open up my email today and be like,
Did you check this morning?
No. Told you I wasn't gonna check.
Yeah. I was like,
I checked last night because all of my trying to find the portal to
Oh,
do the
yeah,
sign up and all that stuff. I was like, I need all those links that were inside my government email. But
Yeah.
no, I'm not checking this morning.
yeah, I was like, I'm not even gonna bother looking. That's funny that Aaron made it here. But
I mean, he was coming slightly differently because I don't know if like AMSO paid for that.
yeah, I would imagine.
Because if they're
I don't
doing,
know. I mean, AMSA, they didn't pay for me either. No. No, I found
paid for you?
Yeah, we ended up getting like $5,000 for all of our staff between now and like January.
Yeah, because it's just the season.
Yeah, and so I paid up like $2K a year, but everything else we go to is paid for by somebody else. So.
I've been trying to read that like Doc is paid for FSP.
Yeah, they're same.
I make JMC pay for Capstone.
Yeah, and then Intel C is paying for me to go to the C2 stuff.
I guess we're up. Yeah.
Here's the pointer.
And it just points out.
Yes, it doesn't.
Right now. Thank you. Pointer. It's pretty dim, but.
Okay, good morning and welcome to ITSEC. This is the best tutorials track all day. I'm Lee Lacey from SoarTech, an Accellent company, and I chair the best tutorial team for the tutorial subcommittee. I'm also the chair of this session. The session includes the best tutorials that were reviewed by the ITSEC committees. And one of them will be selected as the best tutorial on Thursday night at the banquet. The deputy chair for this session is Greg Roulette, a program director at NOC TSD. He's going to be handing out some survey forms. We'd appreciate it if you could fill those out so we can improve next year's conference. A few reminders. Please make sure your cell phone is off or silenced. Each of the tutorials is going to be 80 minutes for the presentation, and then we'll have 10 minutes for Q&A. You might have seen a QR code on the table of contents slide. You can disregard that when we're not using that QR code. If you need to leave before the presentation's over, please use the door back there, not the side door. There's no flash photography, and please do not do any video recording. You can take a still photo of a slide, but please don't video. All conference registrants are eligible to obtain CEU credits, so if you got scanned at the front door, you'll be eligible for those. And after the 3 tutorials today, the ITSEC Fellows presentation is going to be in this room at 4 o'clock to 5:30. So those are announcements. Our first tutorial is Generative AI, and the primary presenter is Colonel Robert Prescott. He's a Functional Area 57 Simulations Officer, FA 57, and an Armor Officer. He works at the U.S. Army's T2COM Futures and Concepts Command as a Modeling and Simulations Officer focused on the integration of joint service and multinational capabilities into Army operational concepts. His co-presenter is Colonel Sean Fraser from the Army AI Integration Center. Please join me in welcoming the presenters to the stage.
Good morning, and welcome to Generative AI, applying off-the-shelf tools to professional military educational wargaming. I'm Lieutenant Colonel Robert Prescott from the U.S. Army Futures and Concepts Command. Sean?
Hey, so Sean Fraser here. I'm also a Functional Area 57 and a basic branch armor officer at AI2C, Artificial Intelligence Integration Center.
So I do have to start with a quick disclaimer, or a pair of them. You might notice that I left most of my voice back in Virginia, so please bear with me. Also, and more unfortunate, Lieutenant Colonel Blair Wilcox was the third part of our trio. He could not make it down here for this presentation, and he was the lead for the Army War College experiment. So for the R North case study, I'm afraid you're getting the B team for the presentation today. So this morning is not about some not even imagined human-machine integrated system of systems of 2026 or 2036. This morning is about the tools we can access right now and how we, as action officers, can use them to solve immediate friction points in wargaming. This is our roadmap for the next 79 minutes. I'll start by baselining some definitions of AI and wargaming. Lieutenant Colonel Fraser will walk us through specific capabilities, risks, and the practical framework for application. Then, I'll return up here to deep dive into our 2 use case studies, a recent R North experiment and a future use case in applying these tools to future force analysis at FCC. So we designed this tutorial using Bloom's taxonomy. We aren't just here to share information. By the end, we want you to be able to identify where GenAI... Don't need the pointer anyway. By the end, we want you to be able to identify where GenAI might fit into your life cycle. Apply it to the 4 phases of a war game: the design, development, execution, and assessment. Then be able to evaluate the risks, knowing when it's safe to use and when it might be dangerous. So before I go on and start to define generative AI, I need to lower everyone's expectations. I am an armor officer and an FA-57 modeling and simulations officer by trade. I am not a data scientist. I am certainly not a software engineer, and I can barely tie my tanker boots. But before we go any further, I want to take a quick poll of the room. And no, the question is not going to be who can tie their shoes. Raise your hand if you have used a large language model in the last month to help you draft an email, a policy memo, or, well, heaven forbid, the script for a tutorial. Okay, That's about 50%. And apparently the rest of you are smart enough to not raise your hands because you know this session is being recorded. So, well, whether you admit it or not, we are all touching this technology. So when I tried to understand this technology, I needed to start with the history. Look at the graphic on the screen. Think of this like a set of Russian nesting dolls. Each era of AI evolved within the previous one. The outer ring is artificial intelligence, born in the 1950s. This term was coined back in 1956 at Dartmouth. This is that broad bucket of thinking machines. Compared to generative AI, we've got something called narrow AI that fits inside this sphere here. Think of Deep Blue beating Kasparov in 1997, a peak of narrow AI. Deep Blue was essentially a glorious calculator and won by brute force logic, calculating millions of chess moves per second. Inside that ring, you've got machine learning. This was that shift from hard-coded rules to learning from data. Instead of programming a computer to know what a tank looks like, you feed it 1,000 pictures of tanks and let it figure out the patterns itself. And inside that ring is deep learning. This is where we get to neural networks and the story of AlphaGo beating Lee Sedol in 2016. Specifically, move 37 in game 2. AlphaGo played a move that shocked the commentators. To the experts, it looked like a mistake. A move so unconventional that a novice might play it by accident, but a master would never play it on purpose. Spoiler, the AI didn't play it by accident. But I should tell you the rest of the story. In game 4, Lee Sedol played move 78, a wedge move so rare that the AI calculated the probability of a human playing it was less than 1 in 10,000. Because AlphaGo deals in probabilities, it essentially decided that move would not happen. AlphaGo could not adapt. Eventually, it lost the game. And that is why we're here. The machines are brilliant at patterns, but they become fragile when facing true human novelty. We need the human in the loop to play move 78. And so finally, at the center, we have generative AI, a specific subset of deep learning. So we have moved from machines that simply classify data, tank versus truck, to machines that use those deep patterns to create new content, text, code, imagery. I like to think of it as the ultimate staff officer with access to the S3 shared drive. It can write a new order for tomorrow's exercise instantly. But we all know it's just Frankensteining paragraphs from the last 50 orders it read, or the last 5 orders it read, or just the last order it read. It genuinely creates a novel combination, but every individual sentence is something it learned from the training data. That is the evolution. From calculation to pattern recognition to creation. That's where we are today. So moving to the next slide. I want to give you a snapshot of what this looks like in practice. You'll see a loop on the screen. This isn't just a theoretical model. It's a preview of the framework I'm exploring for wargaming as part of our future force studies, which we will deep dive into later in the presentation. For now, just understand the concept. Generative AI is integrated across the wargaming cycle. It takes the artifacts and historic data from a game, processes them, and feeds rule sets and orders back into execution. It can act as an accelerator between human interaction and can facilitate game adjudication. You have to ask, though, what about the data? Well, you haven't learned yet that machine learning models are data hungry. They perform better the more data they are fed. I have this dream of developing an intelligent advisor, intelligent agent for simulations. But something that's missing is the actual data set that would inform a truly intelligent advisor and agent for simulations. So what makes a successful AI practitioner? This is part one. Again, if that earlier cycle is that timeline or rotation that we need to manage, what does it take to actually do it? What makes a successful AI practitioner? I think it starts with the fundamentals on this slide: data awareness and understanding capabilities and limitations. Data awareness, knowing what tools can and can't do, knowing what tools can do effectively and less effectively. Awareness includes problem formulation, translating real-world problems into tasks AI can address. I'm actually coming around to the assumption that every GenAI output is a hallucination. But it's up to us as users to assess the usefulness and validity. There's a phrase in the FA57 community: all models are wrong, but some are useful. We have to know that the model is probabilistic. It's guessing the next word, not stating a fact. And you have to understand that your output is only ever as good as the data you feed it. What makes a successful AI practitioner? Part two. Now we'll get into the execution side. Focus on skills relevant to applying generative AI, integration skills, and adaptability. Here, I think a win depends on understanding your own workflow well enough to know where the tool fits. You cannot integrate a new capability into a process that you don't understand. And since the technology changes literally every week, you have to be adaptable enough to learn the new tools as they arrive. Finally, I'm a humanist at heart, so while technical skills are necessary, I believe the two most important factors here are actually human traits: curiosity and humility. We need curiosity, the desire to engage with something novel and not just stick to the way we've always done it. And we need humility, that self-awareness to admit when you don't know the answer, but also the willingness to learn alongside the machine. If you have those two traits, I think you can be successful. If you don't, the tech won't save you. All right, now let's look at the other side of the house, the wargamer. If you ask 5 wargamers for a definition of wargaming, you will get 6 answers. Then, everyone will start debating the mathematical relevance of D20s versus D6s. And then, we'll start comparing the merits of resin, wood, or gemstone dice. Bottom line, there is no single authoritative answer that satisfies everyone. But for this tutorial, we're going to use Peter Perlo's framework. While his classic definition focuses on decisions made by players, I want to stress a comment he made later on that really drives us home. A war game is an experiment in human interaction. Without human players, there may be a model, but there is no game. That distinction is critical. We aren't using generative AI to remove the human. Some of the more basic questions and answers. So what is a war game? We've kind of discussed that. What is the purpose of wargaming? Again, multiple answers: education, analysis, training, decision support, concept development. It is literally a step in many planning processes. What types of war games are there? Tabletop games, matrix games, simulation games, computer-assisted war games, experiments, exercises, toots. Lots of options. But for here, let's also look at the levels of war games. For simplicity, we broke it down into tactical, operational, and strategic. So what makes a war game? It's not just the moving pieces on a map. It is a system of elements. You have the objectives. That is the principal driver of the structure. The scenario. That sets the stage and gives us context. The database. That is the information that the players use to make decisions. Models. They use translate decisions into game events. Again, all models are wrong, but some are useful. The rules. They dictate the how and the when. And then finally, you have the players. The players are affected by the game, and they affect the game. We'll start over with the sponsor and the designer. A war game starts with the sponsor. They own the problem. They define the objectives. Without a clear objective, we are just playing a game, not conducting a war game. Then we have the designer. They are the architect. Their job is to translate that messy, real-world problem into a structured environment. They build the scenario to set the context. They design the rules to govern physics and friction. They curate the database, the order of battle, and required capabilities. And overall, just like the AI practitioner needs to understand the data architecture, a wargame designer needs to understand the architecture of conflict. Once the game starts, we move to execution. This is where the human element takes over. The players. You have blue, friendly, trying to follow doctrine. Red, the adversary, trying to break it. And green, civilians, just trying to survive it. They are the decision engines. Then you've got the white cell. These are your referees and adjudicators. They bear the heaviest cognitive load. They have to represent the rest of the world, calculate combat results, and keep the narrative moving. This is often the bottleneck in modern wargaming. The analyst. Finally, the analyst. If we don't capture the data, the game did not happen. The analyst's job is to observe the gameplay and extract the insights that answer the sponsor's objectives. We break it down this way because later, we're going to show you exactly which of these roles GenAI can augment and which ones it cannot replace. So that is the wargaming landscape. We have the people, the rules, and the friction. Now, to explain how we actually plug the magic of AI into that process, hopefully without accidentally building HAL, Joshua, or Skynet, I'm going to hand over the mic to Lieutenant Colonel Fraser, and he's going to walk us through the actual mechanics of these tools. Sean, over to you.
Thanks, Rob. Hey, so good morning. Nice to be back here at ITSEC. Despite what he said, I'm not an AI expert, and I'm not actually building it. I, too, am a dumb tanker, turned 57, that just dabbles in experimentation on AI, which has been my role for a while now. So I've looked at a lot of capabilities. So I'd like to talk a little bit about some of the opportunities, some of the ethics and biases or risks, and then across really the types and phases of wargaming, and I acknowledge, types up here really kind of purposes, how I'm going to define that out. So we're really going to look at four primary purposes, which are the educational one. Again, that's driven by your learning objectives, right? What do I want my students to learn or grow in the basics concepts of? For training, what are my training objectives, right? What do I want my training audience to grow in the capability or capacity to perform? For experimentation analysis, which has been my bread and butter for the last 5 years, that's driven by learning demands or study issues or learning objectives. There's a lot of different phrases people use for it. But really, what do I need to understand more clearly to inform some sort of decision, right? Money spent, organization changed, et cetera. And then lastly, course of action wargaming. That's driven by mission, right? How best do I accomplish a mission? Also known as course of action analysis, if you're familiar with the military decision-making process. But that informs in the act of execution, if that makes sense. So each of these has a distinct purpose, and we got to remember the purpose throughout this, and then a risk profile, especially in relation to the deployment of generative AI. But really, in any context, the risk is different for each of these. So for the purpose of this engagement, I'm really just going to orient on the first three of those: education, training, experimentation, and analysis. Though I am highly interested in the course of action wargaming, I'm not really going to dive into that here today. All right. It also varies significantly across the phases of wargaming, as you see down there on the bottom. That goes from wargame development, scenario development, through wargame execution, all the way through kind of the end analysis and after-action review. And that really works well with my Army brain: plan, prepare, execute, assess, right? If you can follow that mentality, you can do it pretty well. So I'm going to talk a little bit about a framework for how we assess kind of where the opportunities are for generative AI inside of this, and then where caution maybe is a little bit warranted, or where the risk requires some additional consideration. All right, so again, generative AI isn't just chatbots, right? There's a lot of components to it. We're talking a suite of varied capabilities, from natural language processing, image generation, RAG, or retrieval augmented generation, prompt engineering, as it is commonly referred to, although I think that term is dying off a little bit. But these tools can support everything from scenario scripting to dynamic adjudication. But we got to consider, while we're doing this, other things like deployment models, right? Cloud versus on-prem, subscription versus open source. How context windows and fine-tuning are going to affect performance throughout our iterations. And all these factors can get a little bit fuzzy when you start to see a number of different pathways to pursue with access to large language models, right? Do I use Camo GPT, plug for AI2C, or Ask Sage, right? Which is widely available to the Army. Should I pursue access to an on-prem solution from Scale AI, or secure an open source model from Meta or whoever? Or do I get a subscription from Google, XAI, OpenAI, et cetera? Understanding the capabilities of each one of those and then how it relates to your intended outcome. Again, back to those purposes I talked about. You also have to consider that you want to avoid the shiny object syndrome, right? The new thing out there just to do it, right? Not forget that there's other ways to employ AI that have been around for much longer, as Rob talked about, that may be a better fit, though sometimes those have a higher barrier of entry inside of your capability, right? It takes a lot more time to train a reinforcement learning model than it does to just access an open source generative AI. So a couple of examples, with a number of models, I can use RAG to upload large amounts of reference data and unlock kind of a more tailored system to my specific event. With some models, I can do some back-end engineering, prompt engineering, if you will, to do and temperature controls to improve the reliability of the output that I'm getting from a particular model, for a varied by participant even. And then I can kind of control the factuality versus creativity with most models. And then I can always use, the plain old chat function in there, right? Iterate on ideas back and forth. It's like having a buddy or that junior staff officer we talked about. It can really review your products and prompt other thoughts to come into your head and think a little bit deeper about that topic, right? People sharpen each other through engagement and through communicating back and forth. That's why, if you've heard BogSat, wargaming, that's why that's a thing. And then generative AI can do this to a certain level. All right, now the flip side, right? There's risks and ethics associated with this, and you own the responsibility if you're using it, right? Generative AI introduced risks, particularly in the form of bias, hallucinations, overtrust, and data leakage, right? These aren't just technical concerns, they become operational concerns if not properly mitigated. Imagine a war game where, sorry, I'm losing my voice a little bit like Rob here. Imagine a war game where a generative AI misrepresents the intent of an adversary, or fabricates terrain features or whatever else, while human operators are placing too much trust in that system, right? Overtrust can obviously have a dramatic effect on the outcome of the war game. And then some models have been biased in how they've been developed and the training data that's been provided. But trust is a concern both ways, right? Too much trust results in overconfidence in generative AI outputs, while too little trust can really result in a lack of engagement or poor usage habits, right? If I don't trust it enough, I may not use it well or invest the time to do it well. There's a fair amount of naysayers who are unwilling to unlock additional productivity with generative AI because they see it as an all or nothing solution, but it doesn't have to be, right? We need to treat generative AI outputs as advisory, not authoritative. And we got to build safeguards into our workflows. So additionally, as we talked about briefly, data protection is often a major concern, for us in the Department of War, as well as defense industry gamers. But this goes back to your capability assessment, right? Am I using on-prem versus cloud solutions, open source versus subscription? You need to assess and mitigate your risks throughout this process. So how do we do that? Glad you asked. All right. My proposal is really, you got to use generative AI, obviously, for low-risk task first, right? Generate reference material, brainstorm injects, agendas, concepts. To remember, it's advisory, not authoritative. The first use probably should not be replacing a participant, just augmenting their capability and or capacity to do something. And then you can start to layer in, validation or play testing or expert oversight to verify results. And then fine-tuning is another one. You can fine-tune to a specific topic area to improve your outcome and reduce the likelihood of poor model outputs or hallucinations that are, divergent from what you are willing to accept. This can also ensure, multiple perspectives instead of just one team using chat interface. So if you have multiple people using different chat interfaces, you can get different perspectives in there and start to mitigate some of the risk of one model hallucinating. And then also broad use by that variety of wargame participants can also reduce drift in understanding as well, right? You reduce the likelihood that you're drifting in relation to the training data from that if you're using multiple models. I'll talk, I'm at 57, so I'll talk about VVNA, verification, validation, and accreditation. We got to do that for AI-generated content as well. There are some large industry teams that do benchmarking or evaluation of various models, right, and advertise that out. I think that's a great start and something that we need to continue to do. But also, we need to remember, as we talked about, we need to have humility. Sometimes in our hubris, we forget to consider the level of expertise and reliability the average human participant has in wargaming, especially when we critique model performance, LLM performance. You can't expect perfection, right? I won't get it from people, and I'm not going to get it from a generative AI model either. And if I'm getting perfection from it, then, where are we at, right? Why do we even need the people to be part of it at all? I don't think we're going to be there. Finally, in experimentation and analysis war games, a level of accreditation that the event is on track to inform the decision should be considered, right? For a great process on this, and I know I saw a couple of them in here somewhere in the back over here. The Maneuver Battle Lab has a tutorial later today that talks through the accreditation of an entire event. They're talking constructive simulation, but you got to think about it from that perspective, not just accreditation of a particular model, but how are we accrediting a larger event that it's getting after our intended purpose. All right, so how do we think through the application of generative AI to our particular need in wargaming, right? We're going to walk through kind of the phases here, right? So in development, generative AI can assist with ideas, rule books, references, kind of the where do I start sort of things. You have your scenario design or development portion where it can generate images of terrain or injects that need to go inside there. You got education, execution, where it might support the facilitation or act as a cognitive advisor to the facilitator or participants. And then analysis, it can really help consolidate notes or summarize gameplay. But in every phase, your risk tolerance has to guide how you use it, right? Educational games are going to be inherently low risk. The worst outcome is a lesser educational experience that you can really correct through future leadership. You can correct through instructors, through more education, through future training, et cetera. There's a lot of opportunities to correct, a bad model output from education. When you dive into training, I think you move up into the more medium risk category, right? You don't want to build bad habits because bad habits in training translate to bad habits in execution, right? And so poor AI outputs can help build bad habits. That is a real thing. But there's still opportunity to mitigate this, right? Wargaming is just one portion inside of training, but you've got rehearsals, you've got live training, you've got constructive simulations, you should have engaged leadership that can really help overcome a few bad outputs during a war game and help turn that into a learning moment, not something else. So let's not write it off there either. And then finally, where I think you move into the higher risk category is experimentation analysis. Again, going back to this is informing some sort of tangible decision that we're making, right? Poor war game outputs can lead to poor decisions. So we need to be cautious here. This could be on future capabilities, concepts, force designs that impact our ability to have future war-winning readiness. All right, so I'll kind of quickly walk through a couple of things in here, and I'll kind of convert this over then and go one by one through the educational training and experimentation ones. But first, kind of moving from left to right on war game development. So for the war game development phase, I may use generative AI to support the development or review of rule books, references. I could develop counters with it. I may use it to help perform initial research. This is my particular favorite one, and help scope the war game. I may seek large language model assistance in the validation of my ideas or thoughts. So I know it's not just me saying it, but I can go and validate it. But you got to be dangerous here. It can be like a yes man sometimes, right? So you need to use cautious in that. Make it red team you. For advanced thinkers, it may be suitable to employ a war game to help the development of requirements or a code base for a digital tool in wargaming, as well as assist in the validation of that war game. And then finally, play testing new war games against a generative AI seems like an interesting use case to me, though I haven't particularly done it. But it may not be the best place to start for your first use case. And then really all war games need some sort of scenario, right? For scenario development, I may use generative AI to help source or generate maps. At AI2C, Artificial Intelligence Integration Center, one of our scholars worked on a tool that supported the generation of a road to war, right? And you could associate relevant PMISI, PT, or ASCOPE, it's written up there if you're not familiar with that, or weather data through back-end prompt engineering. And then I may also use large language models to generate additional surrounding context for what I'm doing. This adds realism and complexity of information that may be important to your learning demands, particularly on the education side, but it could be a good training objective as well. And then, as is the case in every phase, I can simply use it to bounce ideas off and help myself think a little bit deeper. All right, and then during execution, I may get a little bit more daring and use a large language model as support as a facilitator, or more simply to support myself as a facilitator with workspaces using RAG or to reference the rule book or the scenario. I may also want to have a set of doctrinal references available via RAG for participant reference as needed. You may want to do this for the threat as well, particularly if it's an unknown or lesser known threat. I could upload ATPs or threat assessments, depending on classification. But that's an important use for it. And then I could use it to develop injects for players to respond to as well. This really adds realism to the scenario and can be contextualized by a generative AI if you use RAG to give it all the appropriate information up front. So setting conditions for the use and generative AI in this manner, occurs during wargame development, right? You have to set conditions early on in your planning for you to be able to effectively employ it come time for execution. Don't decide the use of it last minute. Plan it out with the rest of your wargame. Don't think of it as an easy button that requires no effort. It will fail if you think about it that way. And by it will fail, I mean you failed or I failed to appropriately plan, right? Plan, prepare, execute, assess. We got to do all those things. All right, finally, during the analysis or AAR phase after action review, I can employ large language models to support data analysis of structured and unstructured data, help me with formatting and organizing information, generate reports or consolidate daily notes into one document. This is an area that I believe is particularly underexplored or underutilized right now. If I have terabytes of data that nobody ever references, particularly unstructured data, that's probably far worse than an occasional hallucination of an LLM, right? That actually enables me to actually use that data effectively. And I'll talk about a use case of this on the back end, but if I connect my large language model to read that data directly from the game, and then even enable it to see the game board as well, I may significantly increase what I'm able to use generative AI for, especially during the final phase. All right, back to a little bit more abstract look. I want to dive into the scenario side real quick. So really think about this. You got to help yourself think. Generative AI can also help structure, speed up, and deepen your thinking, right? Think about mnemonics like DimeFill, PMISI PT, METTC, and ASCOPE, if you're familiar with those. They're on the bottom of the screen there, if you're not. But they're foundational ways to express information in relation to military planning, right? Generative AI can generate reasonable scenario context, injects, civilian or infrastructure profiles, and or terrain or infrastructure features aligned with these mnemonics. But again, it's a tool, not a replacement for expertise. So let's expand on that a little bit, right? It can help define mission types for any of your forces that are out there, force postures, terrain, civilian considerations. It can help define cyber threats, urban environments, and population attitudes. These elements feed into scenario realism, but must be grounded in validated data and doctrinal relevance. Grounding it in reality is often where RAG, fine-tuning, and human validation come into play. So here we see how generative AI can support scenario construction by integrating operational variables from weather and infrastructure to enablers and timeframes, can rapidly generate plausible conditions. Remember, plausibility isn't accuracy or relevancy to the objectives, and human validation remains essential to ensure those aspects. Employing LLMs to generate synthetic information relevant to a particular area and time frame will drastically reduce the time needed to develop scenario products. Think about me asking it to develop, weather for the Pittsburgh area the first week of December, right? It probably has a better appreciation of what that looks like by its data than most of the people in this room, right? Again, may not be perfect, but compare it to yourself. So let it do the thinking and gathering of information, focus your mind on more critical decisions, and then the nuanced aspects of wargaming to make sure we're aligned to those purposes. Employing RAG, prompt engineering, and iterative chat can significantly speed up the scenario development process and greatly improve the depth of the final scenario products. Lastly, don't forget to link it back to the overarching objectives. The war game is designed to achieve objectives, not designed to use technology. Objectives always remain paramount. Even if you're going in to try and test the use of an LLM in a war game, give it fake objectives and seek after those objectives to ensure that you can get those, right? That's the validation. That's the true measure of it. When possible, feed those objectives into the large language model as context for the scenario, right? You can't hold back information and expect it to know what you are thinking. The same as if I'm giving a task to a junior staff officer, right? I got to provide it the appropriate context, the 5 Ws, the things I would put in a mission order for it to understand, go, and execute. All right, so I'm going to try and speed through some of these so I don't run out of time and cut short any of Rob's covering down for Blair.
It's all right, Sean, we're actually fast.
Oh,
So keep going. Talk slower.
I'll talk slowly. Well, in that case. All right, so let's pivot a little bit to talk about the potential utility of generative AI by Wargame and across each phase. So for educational games, generative AI can support facilitation, scenario development, post-game analysis. You could feed it in initial objectives and liberally use it to shape the wargame development. Risk is low and mitigation is straightforward. Use the instructors to validate the outputs. If nothing else, it'll promote healthy discussion, which is pretty much always enhances learning, right? This is where generative AI shines, right? Enhance learning without compromising integrity. Go wild in educational wargaming with LLMs. Use it to shape objectives, develop draft rule books, rag in references, develop a road to war and scenario products, and then get advanced and let it help you facilitate the game. Use it to develop learning assessment metrics or rubrics for use, and then allow it to see the game and provide feedback on actions taken, right? The risk is truly low here. This is the best place to explore new methods of use, up to and including using LLM as an agent or a player within a game. Again, that's probably not your first use, but it may be something you want to get to. All right, so moving into training, right? In training environments, generative AI should be slightly more constrained. It may support inject generation, the consolidation of information for daily hot washes, scenario enhancement, and context. The risk is moderate, as bad habits learned in training often translate to bad habits in execution. We, much like AI, quickly fall back to what we have been trained on. The exploration of AI use in training war games is really mitigated by experienced leaders, clear training objective focus, and deliberate planning. Use generative AI to accelerate planning and recap, but keep adjudication and the movement of forces or systems human-led for now in training. A hybrid model is key. How do I maximize human focus on the most important factors through the employment of AI assistance in the development of time-consuming products? I believe access to game data and image recognition of what is occurring in the game can enable quality insights worth considering in the AAR when you get there. Subject matter expertise validation of outputs is wise, but not necessarily essential in all aspects. There are times in there where you can assume a little bit of risk still in training. And then finally, for experimentation. So risk is high, right? So use generative AI primarily for adversary and data processing and visualization roles only, right? It consists with data analysis, structured and unstructured, scenario realism, and DCMP, data collection management plan development. Use it to help you think through the problems more deeply on the front end, but use caution in the outputs during the execution and analysis. Have a process to validate those, right? Outputs must be validated, traceable, and documented. This is where generative AI meets its potential defined limits in here. So I'll close my portion with kind of a personal example here. During one Army experiment, I used generative AI to kind of sort through thousands of observations coming to me, which would have been otherwise impossible for me to do in the given time frame that I had, right? This allowed me to focus on the most important ones and weed out the less mature insights coming out of there. Could it have missed some? Yeah, absolutely. But I certainly would have missed a lot more relevant observations had I not used it. I forced it to provide me links with the exact locations in the data repository where it was referencing unstructured data so that I could always go in and validate that it was a genuine outcome, right? Whoever has seen a hallucinated reference in a paper before, I've seen it. Don't let it make things up on you, but you own the responsibility to validate it, right? This changed my work drastically and created a level of efficiency that was absolutely unachievable without it. I was able to extract mature, evidence-based insights and use qualitative outputs that I am still responsible for every word of that I wrote for each insight, right? AI is simply a tool to improve efficiency and accuracy. It is not designed to replace human responsibility. I'll be followed again by Rob.
Okay. Poll time again. So, once more, I would like everyone who has been a Wargame sponsor to raise their hand. All right, keep your hands up if you have, well, now raise your hand if you've been a Wargame designer. And then a Wargame participant or player. And a Wargame analyst. Okay? Appreciate that. Very well represented here. Now that Sean has shown us the scenario cloud and that clean, logical matrix of how AI could and should work, we'll keep going forward. In systems engineering, there's a concept called the chaos monkey, where you intentionally unleash a digital monkey to smash things just to see what breaks. In wargaming, we don't need code for that. We just call them players. And that means we get to pivot turn now from the theoretical application to the actual application. First, I'll walk you through the Army North experiment. This was a specific test of integrating AI into current staff planning process. Then we'll zoom out to the continuum of experimentation at Features and Concepts Command, where we are looking at the concepts and design of the Army of 2040 and beyond. All right. Just like that earlier caveat, apologies that you are getting the B team on this Army North experiment. But I'm going to try my best and put my Lieutenant Colonel Wilcox hat on and walk you through the generative AI experiment that they use with Army North at the U.S. Army War College. This was in collaboration with CDAO, GuideX, and FCC. The bottom line up front, this wasn't a simulation of a tank battle. This was a war game focused on theater-level war plans using a generative AI system. I can't go into the specific details of the game. I'm not going to do it even if I could. I was not in the room, and my specific role was in facilitating the integration of a GenAI toolset into the AWC process. I knew of a shiny object, wanted someone to use it, and the War College needed that shiny object. However, if you find us afterwards during the week, we can share more information. So what was the War College's thesis statement? Generative AI has the potential to revolutionize military planning by augmenting human cognition. And achieving this requires rigorous training, a shift in approach to augment human judgment rather than replace it, as well as significant technological advancements. The slide in front of you shows the layout of players and the location of the AI cell. This is a small-scale integration. This was a 10-month game development cycle that culminated in a week-long execution in May of 2025. They had blue, red, and white cells as usual. There was also multinational representation and other important agents. The GenAI system embedded directly with the blue operational planning team, an AI terminal that was built on Llama 3.3 and GPT-4. The War College only had 2 licenses to this system, so instead of giving it to everyone, they had to be surgical. They embedded it specifically to test if it could act as a staff officer. It was examined primarily through the lens of the blue team, with white cell considerations as well. The War College team looked at 4 potential roles for the AI before they made their decision. The same roles that we look at for our participants in a war game. The scenario developer, building the narrative, the adjudicator, deciding who won, the designer, building the game itself, and an advisor, the cognitive support for the players. Their decision was to focus their primary research on execution. Then they drilled down on the advisor role. They wanted to know, can this thing think with us? Could the AI function as a member of the OPT? Could it sit at the table and offer a valid opinion during a crisis action planning cycle? The result? It was excellent at narration, taking a dry combat result and writing the CNN headline for the players. It was mixed on adjudication. It struggled with subjective nuance without a human sanity check. For example, when asked what the blue team should play, the cards, the AI gave an answer that was fully within the expectations of the operational planning team, but it could not actually explain why. That conversation actually forced the blue planning team to improve their own explanation of why that course of action was acceptable and useful. So here you see the messy whiteboard. This slide is one of my favorites because it shows the reality of developing a war game, integrating new tech, and has that proverbial do not erase label atop the entire scene. It's real and it's messy. Let's keep going forward. So what were some of the assumptions about the scenario for this war game in relation to generative AI? The first one was that increased operational tempo compresses planning between strategic, operational, and tactical levels. And the second was that there is a need for AI to augment human cognition in decision making. Here you'll see a breakdown of the daily wargame process. 13 excursions across 3 days. Again, for GenAI integration, the War College focused primarily on execution with a secondary focus on scenario development. The War College did not formally evaluate wargame development and post-execution analysis. So let's move to the first critical observation. Training on the tool is non-negotiable. You cannot just drop a GenAI tool into an operations center and walk away expecting success. AI must not be introduced to staff without prior training on its limitation and biases. They found that if the user didn't know how to prompt the system, how to act as a handler, that AI was effectively useless. I think that means that we have to train officers to be AI handlers, just like we train soldiers to be RTOs. And personally, I would also argue that we should not introduce any tools into any ill-defined processes. This brings us to the second, and in my opinion, the most misunderstood insight: course of action collapse. There's a common misconception that GenAI is an awesome idea factory. We want to sit down at the desk, pick up the mouse, bring it up to our mouth, and in our Scottish brogue direct, computer, give me 3 creative ways to seize the objective, and then expect it to spit out brilliance. I think that is a flawed approach. When you ask GenAI to generate ideas from scratch, you will get generic hallucinations that may carry the commander's guidance but lack the commander's intent. You will get quantity, but not quality. What Army North found was that the toolset was best as a refinement engine. It works best when we provide the ideas and it provides friction. We call this course of action collapse. The staff builds the initial courses of action because we, the staff, understand art, nuance, and acceptable risk. But FYI, those courses of action should probably be complete, but they do not need to be perfect. Then we feed those courses of action to the AI and say, scrub this against doctrine. Tell me why this fails. Generative AI can act as a doctrinal filter. We can ask, how complete is this course of action? And then the GenAI tool can point out that we forgot the entire concept of sustainment. Or if you're a former Armor Officer 19 Alpha, you neglected the other categories of supply outside of beans, bullets, and gas. But less about me, sorry about that, and more on generative AI. In its best version, GenAI didn't generate the plan. It iterated and refined the plan with the staff. It collapsed the decision space from numerous mediocre options down to the viable ones, saving the staff hours of wasted planning time. Moving forward to the third insight. Call this one alternative futures. So while the staff was hyper-focused on the plan, the accepted course of action, the AI is still available, running in the background. It can be asked, what if red does X? Or what if this alliance falls apart? It allowed the staff to explore counterfactuals, alternative futures that they simply didn't have the bandwidth to consider before. An ultimate red team member that never got tired. Generative AI can enable the exploration of branches and sequels more quickly by increasing the speed of access while still limiting the loss of quality. Now, the fourth insight. Generative AI systems can provide valuable insights during post-game analysis, summarizing lessons learned and evaluating player decisions. GenAI post-game analysis extracts potential we usually leave on the table. The AI remembers everything. Humans will forget why they made a decision on turn 1 by the time they get to turn 5. The Army North Wargame tested GenAI's ability to enhance cognitive capacity in military planning. AI integration can promote crisis action design by enabling rapid, precise feedback and expanding the input of all the warfighting functions. The War College landed on 4 validated principles for future experimentation on GenAI integration. First, train human operators before AI implementation. Second, prioritize course of action collapse over course of action generation. Third, use GenAI for alternative features analysis to expand understanding. Fourth, leverage post-game analysis with generative AI to enhance insights and lessons learned. Because there is a difference between the Minotaur and the Centaur. Where are you going to put the generative AI? Are we leading it with the human, like the Centaur, or are we letting the machine lead the pair, like the Minotaur? So Sean and I have been talking for nearly an hour now. So apologies, or you're welcome for putting you to sleep. But now is no time for a poll. Raise your hand if you have wargamed the past. Raise your hand if you have wargamed the present. Now raise your hand if you have wargamed the future. Now, we're going to pivot from what happened at Army North to what some of us are looking for at Features and Concepts Command. While Army North was a focused experiment on staff integration, our work at the Features and Concepts Command is exploring how modern and emerging capabilities can support future force studies. We aren't just focused on one game. We are looking at how generative AI can support the entire spectrum of experimentation, from tactical exercises without troops, toots, to theater-level joint war games. We're asking, how can GenAI support the Army modernization enterprise? How can GenAI act as an intermediary between subject matter experts, our doctrine, our rule sets, and the wargamers? Our focus is going to be on scenario development and then analysis and AR, but we're hoping to explore all 4 roles for generative AI. First, We can view a war game as a pyramid. And I want you to look at this through the lens of a battle staff first. Think about how we build a functional staff. It isn't just one person. A staff is a complex adaptive system that performs greater than the mere sum of its parts. At the base, every staff officer goes to professional military education to learn doctrine and future concepts, and this provides a common language and functional expertise. Then they come together as a unit. They learn performance, history, lessons learned. They learn their unit SOPs, how this specific team fights in the real world. Each member of the team also brings along their own individual history, shaping the performance of the larger staff. Then they deploy to a specific operational environment. Much of my experience is in the Indo-PACOM area of operations, an environment that might include simultaneous operations on either side of the international dateline, with forces home-based amidst the snow in Alaska and in the red clay of Hawaii. Now, and only now, is that staff ready to operate within that specific war game scenario at the top. Where might GenAI play a role as an intelligent agent or advisor? If we incorporate war games with that foundation of current information, lessons learned, and base it in our published doctrine or emerging concepts, GenAI can help close that gap, again, between the data and the player. Now, this overall lens of the battle staff is critical for improving AI integration. If I just focus on the top of the pyramid, it's like tossing a bunch of random soldiers into an operations center and asking them to run a division fight. They don't have the foundation, so the outputs are expectedly not great. To integrate AI as a tool, we have to build its mind using that same sequence and then integrate it into our processes. First, we use RAG pipelines to give it the doctrine and concepts. Then we feed it the history, the AARs, and observer, controller, trainer reports for context. Then we use natural language processing to translate the commander's intent and mission orders into machine-readable formats. Maybe this is merely for digitization, but this could also generate the movement orders for simulation. Then we use LLMs to adapt and define the environment. Our scenario must be different between Alaska and Hawaii. Now, with that full context, a GenAI tool can become a competent member of the staff in wargame design, execution, management, and participation. So how do we apply that pyramid to the design phase? We start with the data. We have an abundance of it. Doctrinal templates, force design workbooks, task organizations, AARs, and lessons learned. But right now, that data sits in binders or PDF repositories. We know GenAI output. We know that generative AI output is biased by its training data. So, in the development phase, our job is to bias it correctly, to give it our data. We feed it the force design updates and the concept of operations so it understands what we are testing. To represent competitors, we provide reports from training or intelligence communities. And then maybe we can design war games that respect the complexity of multi-domain operations, rather than just hand-waving the non-kinetic effects. Look at this multi-domain operation snapshot. Hope it's going well. Look at this multi-domain operation snapshot, and you'll see a complex network of integrated capabilities. In multi-domain operations and systems warfare, the complexity is simply too high for a single human adjudicator to track every second and third order effect. In a complex adaptive system of systems, we may never be able to fully predict the outcome of system interactions. That's why we play the game. Here's the use case. If a red cyber effect in space degrades a blue logistics node on land, A human referee might miss that link because they are focused on the maneuver battle in the center. But if we have done our job in the design phase, if we have trained the agent on the communications architecture and the sustainment doctrine, the AI won't miss it. It will tell the adjudicator, sir, because that satellite is down, this convoy cannot move. Performance and history is next. Crucially, we can also feed GenAI historical artifacts, like the data and observer controller reports from the combat training centers, or the summaries residing in our lessons learned databases, like this fictional example on this slide from the 11th Airborne Division. We want an experimentation and training system that leverages institutional memory. We want to be able to move beyond lesson observed and actually towards lesson learned. Let's actively work to leverage the mountains of data we already collect to make our training events more efficient. Another key and real value is in adaptability. Too often, we re-execute last year's exercise. We change the dates. We swap the unit patches. GenAI lets us break that cycle. When we do that, the schema maneuver culminates in the same combined arms breach. We test what we are comfortable testing, not what the unit needs. If a previous rotation, the unit did amazingly at movement and maneuver, but struggled with sustainment, the AI can analyze those OCT reports and help us redesign the scenario to specifically stress logistics. It moves us from canned training to needed training at a speed we couldn't realistically achieve before. For the scenario and operation environment, this architecture allows us to improve upon one of our biggest challenges, iteration speed. Another quick poll for the room. Raise your hand if you have ever had to plan a major exercise and you just went into the shared drive, dug up last year's op board, changed the dates, maybe updated the location from Atropia to Denovia, and hit save. Raise your hand if you've recommended someone else to do the same. Wow, there was not a lot of hands in the air. Still, I think the answer is about 80% since I'm counting the people who should have raised their hands. But it's okay, this is a safe place. But let's ask, why does this happen? Well, we have an answer. Building a new scenario from scratch takes months that we don't have. The problem is, we end up training the same problem set for 10 years straight. Traditionally, if we want to change the environment, we have to manually rewrite hundreds of injects and background papers. It is tedious, prone to error, and actually detracts from realism and immersion. Now, we can change the variable in the operation environment layer of the pyramid. And the GenAI tool can propagate those changes across the entire scenario nearly instantly. I like to call this often GenAI for the mundane. Take a common inject in the master event scenario list, a simple email from a higher headquarters to a subordinate. Scenario A, we tell the GenAI, I'm the task force J3. Write an email to the ground commander and his G3 asking for the air-ground considerations regarding Singapore, Japan, and Korea. Scenario B, 5 seconds later. We change the prompt. Instead, let's ask about the air defense considerations for the Philippines and Australia. Both messages generate nearly instantly, and they still contain the expertise and doctrinal references expected from those echelons, as long as the appropriate data was made available. We are asking GenAI to write the hundreds of often mundane messages that make scenarios feel real, so planners can focus on the decisions that actually matter. If I could buy an action officer 5 more minutes each day to focus on something more important and multiply that across the area of operations in an event lifecycle, then maybe those planners can get home a little earlier. Just kidding. We'd find something else for them to do for those 5 minutes. So let's bring us back to where we started. the elements of the wargame, and look at how we actually can apply this off-the-shelf tech. Objectives. It starts with the sponsor, usually a commander. Instead of guessing what they want, we use natural language processing to translate their commander's intent and clear mission orders into data the system understands. We ensure we aren't just playing a game, we are solving the commander's problem. The scenario. This moves us from a static binder on a shelf to an adaptable and accessible database. If the world changes this morning, the scenario database can change this afternoon. Database and models. These are informed by real-world readiness data. Like that 11th Airborne example, so our adjudication is grounded in recorded reality, not just probability tables. Rules. We can take general rules and apply them to specific edge cases instantly. Or better yet, we can use the game results to help us refine future rule sets. And finally, the players. Generative AI lowers the barrier to entry to wargame participation. It allows a novice player or facilitator to get into the scenario immediately, fighting the enemy instead of fighting the game mechanics. We aren't changing the definition of wargaming. We are changing fidelity and speed. We aren't at the finish line yet, but we are close. Based on what we've seen, AI appears most promising for wargames that investigate alternative conditions or focus on evaluation, especially when the problem is well defined. But to get there, we have to be responsible. We need to improve our data capture now to create the robust data sets that will train the capabilities of tomorrow. As we explore integrating all types of AI into our formations, we are constantly wrestling with a few key questions. Data modernization. How do we integrate this into our department's broader data architecture so it doesn't become another stovepipe of excellence? And security. How do we secure and, more importantly, trust these capabilities when we are dealing with classified or sensitive data sets? I don't know the answer, but we're working on it. And now to tie it back to where we started, and to save the last shreds of my own voice, I'm going to hand the mic back to Lieutenant Colonel Frazier.
Yeah, the good news is you only got me for 5-10 minutes here at the end. So really, I just want to circle back to a little bit at the beginning, right? What did we talk about at the beginning? We built it around Bloom's taxonomy, right? We really need to solve a problem, not just admire it, right? We don't need to still look back and say, yeah, it'd be cool if they all work together. Great. The hope here was that we're offering a path forward, not just a problem, that we've enabled you with tools and knowledge to go back and apply on Monday morning after ITSEC, of course. So in line with that, we talked about identifying, right? It's not science fiction. Identify the capabilities that exist today that you can employ to support it, whether it's any type of solution, open source or on-prem, cloud, subscription, et cetera. What do I need? Natural language processing, image generation or recognition, RAG. A lot of that stuff is available right now off the shelf, much of it free of charge. So think hard about it, right? Identify those things that you can employ today, and then apply it, right? The second part of Bloom's taxonomy is apply. Just don't fall back on the old ways of doing things, right? Actually think hard about it. Put it into your planning considerations up front, right? We showed you a little bit of a blueprint about how I think about it, how Rob thinks about it. But think about it, right? Actually go do the planning, do the preparing, so you can do the execution and assessing on the back end. And then evaluate, right? We asked you to think through the risks and the bias and the challenges associated with it and some of the ethics, right? As we talked about in the R North experiment, right? The risk of hallucination is real, right? It will give you some faulty outputs, or it may not be able to explain everything that it does, right? You need to train the people to treat the AI like a junior staff officer, smart and willing, ready to go, but requires some supervision, right? You got to aim them at the right target, You got to provide that supervision to keep them on that target. The risk is manageable, but you have to think about it in the right way. And then finally, really the takeaway from this, in my mind, ultimately, is this is a force multiplier, right? If you remember kind of 3 things out of this, I challenge you to think about these, right? It lowers the barrier of entry to build and execute high-quality games. Number 2 is iterate. You can iterate on scenarios in minutes rather than months, or days rather than years, whatever. And then third, you need the baseline knowledge to check its work, right? It's a tool. It's a wayward staff officer who needs a little bit of guidance. It is not an end-all, be-all solution. It's not an all-or-nothing approach. No person is, no tool is. And you need to think how hard, when you think about it as a tool, you need to think hard about how you apply that tool, right? Even within the world of screwdrivers, there are so many different types of screwdrivers. If I pick the wrong one, it doesn't help me, right? Phillips head and flathead don't mix. You get the little star bit ones, and now you got to go find every size of that. And then, if you go into, the latrines, sometimes you see like the star bit with the little like hole in it, or it's like tamper-proof or whatever, so you can't get into it, right? You got to find what the right tool is, what the right components of tools is within that, right? Sometimes you need to go to a hammer, right? It's reinforcement learning is your best option if you're going to integrate AI, right? But other times you just got to find the right screwdriver. And then I'll close with kind of one comment here, and then I think we'll jump into questions. So leadership and education, right? That's a big component of this. So I think of everything, at least for the past 6 years I have, of doing experimentation in a .mil PFP construct, right? Everybody familiar with that? Anybody not familiar with it? Nobody's raising their hand. Somebody in here is like, all right, we got one. All right, so I'll go into it. All right, so doctrine, right? Organization, training, material, leadership and education, personnel, facilities, and policies, right? That's .mil PFP. You have to think about it in that construct, right? I'm not just applying a tool. I'm applying a tool, and I've got to think about the rest of the ecosystem. We didn't dive into the rest of the ecosystem entirely, but that's a component of planning. And we who think about the future often thinks about it in terms of .mil PFP, because it allows us to go after a construct to say, if I'm taking a material change, which we call software material, if I'm doing a software change, right, I'm using a large language model for something, what are the other things that we also need to think hard about, right? And one of those things, kind of in closing, that we hinted at throughout all of this was the people side of it, right? Leadership and education. Are we educating our people to think through these problem sets? Are we educating them correctly or training them correctly to be able to take advantage of these tools and understand how to think about it, provide them with, equip them with the capability to assess risks, adjudicate those risks, and come out with good solutions that create efficiency, that we're able to get after more where we're at. A friend of mine back at AI2C is working on a paper just about that, right? Leadership and education, and how the AI, the realm of AI, is changing that, right? We need to sustain good leaders who can go back and do the validation. Good leadership has always been an asymmetrical advantage in the United States. We are designed in the Army and in many of the services to build leaders. That's an asymmetrical advantage that we've had for a long time. Our NCO Corps has been the envy of many countries. We need to think about that and sustain that going forward. So I challenge you, in the context of this, think about it in .mil PFP. How are we doing that training and that leadership and education in particular as we're introducing new tools? I'll close with that, and I think we'll jump over into any questions, but I'm going to sit down to do that. Thank you. Sure, go ahead.
Yeah, so I wanted to ask a question actually of that last point, because that was a thought that was kind of reoccurring in my mind throughout the whole presentation. Is I think one of the risks of the use of generative AI models is also expertise development. So I think we have to recognize those processes. And so my question to you is, in terms of professional development, particularly your junior officers or your junior associates within the wargaming team, do you have any sort of device mitigation strategies to ensure that the senior leaders and supervisors are building that capacity among the junior officers and not just kind of going through AI tools and saying, hey, some of these tasks that were kind of a chore to me, I'm able to sort of automate it. How do you distinguish between chore versus chore? Do you kind of restrict the use of GenAI models for staff members who maybe need to build upon that experience until they have developed competency to use them? So this goes kind of beyond just teaching the limitations of the model itself, and it goes down to actually capacity development, particularly for the next generation of leaders within this domain.
Yeah, so I'll take that one and then feel free to hop on. So that's a great question, and I think it's really important. I think there's two pieces to it, right? You have to think about it institutionally, as you kind of talked about, with broad leadership across the entire institution. How do we integrate that into, for our context, professional military education, onboarding processes, things like that as you come to various places within the Army. And then obviously locally, right? In your local onboarding process, what are the tools available to this local organization and how do we best employ them? What are the things that we can and can't do with that? And then allow a little bit of freedom for people to experiment, right? You got to go off and find some time to do things, right? In the software world, a lot of time, they'll think about things in terms of how do I create the freedom of time for people to actually get after coding things of interest or building things of interest, minimal viable products that they wouldn't otherwise build because I've got them laser focused on one thing all the time, right? And I miss some opportunities in there. So I think you have to think about it that way. And then you have to think about it at levels, right? So, at AI2C, we do some workforce development, some education programs, right? And we think about it really, we got leaders, right? How do we create data-driven leaders that understand how to make decisions based on data? What are the capabilities? What are the risks? All those things, right? We got to think about kind of the experts and pseudo-experts, if you will, right? People who are really, really good at these things, and then people who are good enough to help us move along in these. And then at the bottom, you got the users, right? The average user out there that's going to go out and get on an AI platform and interact with it. How are we educating them more broadly? And I think that's the piece institutionally that we really need to get off that the user and the leadership pieces institutionally across the board to kind of build that into military education.
And then I'll probably add on in kind of like a tactical operational way, and I'll use the use case of like the modified combined obstacle overlay and how we task every scout leaders course cohort and every officer basic course to have officers sit down over a map with a green marker, a red marker, and a black marker. That's fine to a level. That's probably not something, when you scale that up to like an entire theater or the entire country or entire training area, that is a mundane task that an AI tool can probably do good enough. Probably just as good as that lieutenant could. Good enough for the whole theater. But there is a line somewhere in between automating something to that AI tool or letting the lieutenant do it, in that you have to be able to trust the output. If I've got as a senior leader, if I've got qualms about the lieutenant's McCoo, I am not going to accept it. I'm going to have to use my own education and experience to say, go back and tell me why this is highly restricted terrain to you, and then go through that process. When we bring that back down, that means I also need lieutenants to go walking around the woods to understand that their tanks can't fit through forests with trees that are 1 foot wide. Like, there is a mix between that live interaction that provides context and then that tool, even if it is a lieutenant, to provide that staff input to a leader later. But if we just remove human experience, then we are just going to get a very vanilla answer. So hopefully that answers the question.
Yes, sir.
What kind of new skills would we require from our staff officers? I think this is a place where like your AI, like officer course would be useful.
Yeah. So I'll think about that in terms, again, we do a workforce development program and we again, across those 4 levels, right? But what are the skills that you need within there, right? I think when you think about the advancement of AI, right, you've taken to where somebody who had no intelligent coding skills whatsoever can actually code minimum viable software products now using AI, right? And barely be able to read the code that the AI produced, right? And it still probably operates at a minimal effective way. That's going across the board, right? So when you think about it in that context, I think you have to think about it as an addition or an additive of skills or an enhancement of skills that people already have, right? You have to think about it in both of those contexts. So how are we improving skills that people already have? And then what are the new skills that are added? I think you have to think about it in both terms, because if you only do one, I think you sell the conversation short. For particular new skills that people have, I think it's going to evolve. I don't think you can say, hey, AI in 10 years is going to look like this. And if you do, there's a 99.9% chance you're wrong, right? I think you can make educated guesses on 3 to 5 years of where we're going to be, but who back in 2021 was talking about ChatGPT or thinking about how do I use generative AI in wargaming? Not a whole lot of people, right? That's 2 years out, right? 2 years before we got to ChatGPT, nobody was thinking about it. So when you think about the skills, the skill is adaptability, right? How do I adapt over time to this? How do I rapidly change, which is hard for a big bureaucracy like the Army or the Department of War? How do I rapidly change constructs and get things integrated quickly and educate folks on it quickly enough to be competent, but don't go so far that I've taken all this time and built this grand education plan to overcome AI, and I've perfected every little skill that I'm going to need, because if I focus on that, by the time I'm done developing that technology is probably outdated. And we're going to need to rethink those skills. So I'd caution, how do we quickly improve the skills that we have with AI is probably the best place we're at right now. The new skills, I think, we think about that at AI2C, and I won't dive into every one of them, but for how we build AI technicians and AI scholars for the Army, how do we build folks that we have resident capability within the government, within the Army, that are able to solve problems rapidly and create minimum viable products out at the edge, and then obviously kick that back to industry, right? How do we translate that over to industry and say, okay, hey, now we've figured out what we want, right? We've helped orient ourselves down and kick that back over to industry, who's obviously going to be leading in those skills most of the time.
And then before we get kicked off the stage, I'll just add that I argue that repetition builds comfort and familiarity. So just for the individual level, I say go out there and use the tools. Don't be afraid. Take your own workflows and apply tools to your workflows. That is the fastest way to learn a system's limitations and its capabilities. It's not going to be us pushing through a bunch of PowerPoint slides. It's going to be individuals just seeing what can happen.